Thanks for attending the Trilithic webinar series. Today I will discuss high-speed data troubleshooting tips. Too often I find that as I go out and do different trainings that there's a bit of a struggle on how to isolate high-speed data problems. What are some of the tricks to the trade in order to efficiently identify, that if there is a problem with data speed or packet loss, things of that nature. I think what we're going to find in this particular seminar that some of those questions will be answered and give you a better grasp of what you're troubleshooting, because I feel that once you understand what you're troubleshooting, it makes it a lot easier for you to make whatever repairs need to happen. In this webinar, there's a chat feature that's provided to you for you to ask questions. At the end of the presentation, all questions that were posted will be responded to. So feel free to jot down any questions that you have. In this particular portion of the series, I will cover how to use and understand high-speed data troubleshooting tools. We're going to talk about what is ping and how to troubleshoot with it. Using the trace route to identify problems in the network. How to use traffic control to measure the return data carrier and to also view any type of interference that may be happening underneath that particular carrier. We'll talk about how to see noise under the QAM carrier using QAM EVS. We'll discuss how to measure the network speed at the customer's location. Then we'll talk about DOCSIS 3 and how to troubleshoot using DOCSIS 2 equipment. Okay, let's now talk about high-speed data troubleshooting tips. Your high-speed data services utilize both the downstream and the upstream. The downstream is streaming data. It's a constant signal, usually 64 or 256 QAM. This is the same downstream type of signal that your video carriers use, similar to your HBO, ESPN, so on. The upstream data is time shared. It's called TDMA, which is time division, multiple access. Upstream data carriers are bursty, unlike the downstream. Because of the bursty nature of upstream data carriers, you have to use certain tools to make measurements accurately on the upstream carriers. To verify that you are not losing any data package, you can do a ping. Ping will both send and receive packets. To ping, you will need to enter a host name or an IP address. It is best to ping a known IP address on your network, since you can only control what is happening on your network. Enter the packet delay to determine how fast to send the packets, and enter the packet size to represent the size of packets that you want to send. For connectivity or delay, set smaller packet sizes and long delay between pings. For packet loss, set small packet size and short delay between pings. But for throughput, set large packet sizes and short delays between pings. If checking for connectivity to another device, a small packet size is recommended. For example, 64 bits and bytes and 1,000 millisecond delay. The reason is some devices ignore pings with large packets, which would give a false indication of no connection. Also, small packets are great for testing round-trip delay and packet loss, but remember, large packets are better for throughput. Also, DOCSIS limits the ping throughput test to the max upstream throughput allowed by the configure you set. You can see the total packets that are sent and received, the total packets that are lost, and the lost packets are expressed as a LPR, which is the lost packet rate, or show the percentage of total packets lost from those that were sent. You don't want to lose any packets, but the industry standard is less than 1% packet loss. The latency and jitter that you see on the display there is calculated by taking into account the codec. This particular analyzer provides ping test, which is a continuous ping. So once you hit your start key, it'll send and receive packets until you press the stop. As soon as you press the stop, then it will show you what your lost packets are. It'll give you your lost packet rate and the lost packet rate percentage. Now you can also conduct a ping from the customer's PC. So after you've already verified that that everything is fine using your 860 DSPI, then go directly to the customer's PC. And by going to their command prompt, you can type ping with a space and then the URL or the IP address that you want to use as its destination. Once you type that, and then just press enter, and then you can simulate the same type of test. It'll send packets and it'll receive packets, and it'll let you know how many packets were lost. In addition, now like with the 860 DSPI, you notice that you can do a continuous ping. You can also do a continuous ping using the command prompt. Just like what I mentioned earlier, you want to type ping and then the URL or the IP address that you're trying to use as your destination. But at the end of it, have a space and then a dash T, a lowercase t. Sometimes it is helpful to run a trace route from the subscriber's PC. This will show the routing point where the transmission stops. Some devices can be configured not to respond to a ping. It's as a security measure, like firewalls, for instance. This is why it is important to know what IP address to ping for your test. I recommend a device located near your CMTS. That way you can test to that location to see if it is a problem on your network. Trilithic provides a server for ping testing to the customers. It's a public IP, 207.250.51.174. Pinging this address would test from your current location through your network and IP backbone and onto the World Wide Web back to Indianapolis, where Trilithic is located. Another great location to test is www.yahoo.com. When at the subscriber's home, since they would recognize Yahoo as a legitimate location. However, neither of these locations would isolate the problem to being just on your network. You can also do a trace route from the customer's PC by typing trace RT with a space and then the IP address or the URL. Like in this example here, it shows trace route, trace RT, the space, www.yahoo.com. This is useful when you're trying to identify where the packets are lost. So let's say, for example, you're inside of the customer's house. So you know that they're having problems reaching, we'll say, Yahoo for this particular example's sake. What you're going to do is once you go into traceroute and put in Yahoo, it's going to show you all of the hops that the packets are taking to reach that destination. So if I had my signal level meter, my 860 DSPI, what I would do first is I would do a trace route directly from that. I would go to Yahoo. If I'm going all the way to there and I'm not seeing any problems at all on my meter, but yet when I go to the customer's PC, they are having problems, then I've narrowed it down to being something that's at the PC. So my next step is going to be is going on the customer's PC with the command prompt and do the same test that I did with the meter. And I would see if I have any increased latency or anything like that when I try to do a trace route. If I do, I'll identify which hop am I having the problem with. If I see that the problem is actually coming from a, let's say it's coming from a firewall issue, then it's going to quickly tell me that because it's going to show up that that particular firewall is showing some impairment. So for example, I could, if the customer's PC is having the problem, then I could use my meter, ping directly or do a trace route directly to the customer's PC, and as it goes through the different hops, when it gets to their firewall, if that is the issue, it won't allow me to go any further, and it'll show me in the trace route. Traffic mode on the 860 DSPI can be used to see the ingress that is present underneath an upstream cable modem carrier, voice over IP carrier, or any type of bursty signal. The frequency span of the spectrum display itself, shown in the above drawing, is fixed at 8 meg, so that you can see 8 meg across. The user would enter the center frequency of the upstream cable modem signal, that digital center frequency, and then also the bandwidth of that particular modem carrier. The traffic mode display shows three traces: a traffic trace, a live noise trace, and a peak noise trace. The traffic trace, which is in gray, shows the last captured signal containing traffic. Now the live noise trace shows the last captured signal without traffic. And the peak noise trace, which is in black, shows a persistent peak hold of the noise trace that's there. So that's what's happening that's happening underneath that modem burst. The measured values of traffic and noise are both total power measurements across the bandwidth, which you entered earlier, or which would have been entered earlier. The delta measurement shows the total signal power to the total amount of ingress that's happening at that particular point. And then you can set your trigger points so that whenever the carrier drops below that trigger, it automatically recognizes it as, okay, there's no modem carrier there, so that's when it starts looking at the noise floor, and that's how it's able to make that calculation. It's important when you're making this type of measurement that you also set your reference level, because by your reference level not being set correctly, this is what measures your input level that's coming in. You could actually overload the analyzer, and it can show you some beats or what looks like distortions that's happening in that particular carrier that may not even be there, but it's all because you're overloading your meter. And it'll actually show you on the meter if it's in an overload state. It'll show that it's overload. Now you can also make a similar type of test using your spectrum analyzer. Now a lot of people use the max hold in the spectrum analyzers, but I find too often that people do not use the min hold. You can use your min hold the similar way that you were using in the traffic mode, but what happens here is that you have your modem burst, and remember I was saying that comes and goes. So what happens is when that modem burst leaves, then what's going to be remaining is whatever is happening up under that particular carrier. So it's going to show you what type of ingress is there, and it'll lock in on that particular signal source. Now, one of the unique features of the H60 that you can also have is what's called QAM EVS. This QAM EVS allows you to look at ingress under the actual digital haystack, which is that QAM carrier that's there. And this is a very useful tool because remember I was saying earlier that with your QAM downstream signal that it's a continuous signal. So if it's a continuous signal, then if there's any type of noise that's happening under that QAM carrier, you won't be able to see it because it'll be masked by that carrier. So what you can do is use the QAM EVS, and when you're using the QAM EVS and the H60 DSPI, the meter mathematically removes the haystack from the display, allowing you to see the noise floor under the signal to be seen. Like in the example here, it shows that the QAM analyzer's peak marker is auto-placed on a beat at a minus 30.1 dB. It's actually below the actual QAM carrier, and then it also depicts what the frequency is of where that beat is. Troubleshooting in-channel ingress with QAM EVS actually makes it very easy to identify problems, because this is when you start seeing these intermittent things, intermittent slow speeds or things like that, and when you get there you check everything and it seems to be fine. Sometimes what that comes from is that you can have just a little bit of ingress that's under that QAM carrier, and ingress comes and goes. So the intensity of that could be higher at different times than others. And when it's higher, then that's when you'll start having those, drop packets and things of that nature. So this will find that for you, and it makes that part of the troubleshooting easier. There's what's called the QAM source. QAM source is a very useful tool to just test out your network, the integrity of your network. For example, with your QAM source, if let's say you've just activated a new subdivision, and you want to ensure that when a customer hooks up an upstream device like your high-speed data, your cable modems, you want to ensure that the customer is not going to experience any problems. From the customer's house or from the end of the line, wherever you decide to use a QAM source, you could send a QAM signal upstream, and then it can be measured inside of the head-end by one of the head-end techs or the head-end engineers. When they make that measurement, they can then look at what the noise levels are. They can measure their MER and see what type of quality that's coming back from the upstream. When you make that type of verification, then you can feel confident that when a customer is installed at that location, that they'll be worry-free. At least hopefully. With the Trilithic's Throughput and ACT server combination, it allows you to test the speed of your network. In testing this, no files are created or destroyed. With most free HTTP and TFTP test server applications, files are created on the server or serve up files from the server, which is a security concern from a malicious virus attack perspective. This application simply creates chunks of random memory and never accesses the hard disk. Customizable ports. Most free HTTP and TFTP test server applications use well-known internet ports like port 80 and port 69, which exposes the servers to standard virus attacks. This application allows the customers to choose the port and thus hides the server from the standard internet community. A side effect of this is that this application can now be installed on the same server as a standard web service, such as the web server or a TDM server or a cable modem TFTP server. Now to recap what we've covered so far in this webinar series, we talked about ping. Ping is useful for detecting if any packets were lost. Remember, when setting up ping, you want to enter the IP address or the URL of the destination that you're trying to reach. It's good to ping something that's actually on your network opposed to outside of your network, because you can control what's on your network. But once it gets outside of your network, if it's a problem with a customer or with a website or something like that, you can't control that. But with this particular using the ping feature, it will at least show you if you are losing packets to that destination. We talked about traceroute. Traceroute shows the path that the packet took to get to that destination that you entered. Similar to the ping, that you want to enter the IP address or the URL. Traffic control. Traffic control is used for detecting any ingress that falls beneath the traffic or the upstream data carrier. Whenever there's data or traffic present, you can't see the ingress that's under it because the traffic will mask what's happening at the noise floor level. Traffic control in the 860 DSPI allows you to see beneath the traffic or that a modem carrier that's on the upstream. QAM EVS, similar to the traffic control, but it detects ingress under the downstream QAM carrier, that digital haystack. Same as the traffic control, that when there is the QAM carrier present, you're not able to see that ingress that falls under it. The 860 DSPI has the ability of mathematically removing that digital haystack, which leaves the noise floor or any ingress that's happening in that QAM carrier. QAM source, that generates a QAM carrier that you can send back to the head end. Your head-end engineer or head-end technician then will have the ability of measuring how much insertion loss, how much loss that you have from the point that you injected that QAM source to where it actually reached back at the head-end. But the other useful thing that you can do is the head-end tech can, with the QAM analyzer, can check the MER, can look at the constellation. Just see, just look at the digital quality of that particular signal. Throughput. Throughput tests the speed. In the 860 DSPI, the throughput option works with an ACK server. That server allows the 860 to send packets and receive packets, and then the speed is clocked. It lets you know what the speed was. Remember, your customers pay for different tiers of services. Commercial customers, for example, will pay for a higher tier. And because they're paying for this higher tier, they expect to have the speeds that you've assured them that they're able to receive on your network. the throughput test will qualify that particular customer and will make them feel comfortable that they are getting what they paid for. I want to now talk about DOCSIS 3.0. But before we dive into DOCSIS 3.0 and what it is and what it does for the company and the customer, I want to just kind of go through what DOCSIS is. DOCSIS is the standard for a data over cable. DOCSIS stands for Data over Cable Service Interface Specification. Cable systems provide higher signal-to-noise ratios than over-the-air transmissions. A well-designed and maintained cable plant is required to meet the DOCSIS specs. QAM is part of the DOCSIS 1.0 and 1.1 upstream specs. 64 QAM is part of the DOCSIS 2.0 upstream specifications. 64 and 256 QAM are both used for digital video and for your DOCSIS downstream, allowing more digital data transmission using the same 6 megahertz bandwidth. The transmit equivalent of 6 to 10 standard analog channels or 2 to 3 high-def streams over a single 6 megahertz bandwidth channel. DOCSIS 1.0 brought you high-speed internet access. DOCSIS 1.1 added voice, gaming, and then streaming videos. It's backwards compatible with DOCSIS 1.0. It also added quality of service, QoS, which is a must for packet cable. DOCSIS 2.0 increased security. It's also backwards compatible with DOCSIS 1.1 and 1.0. It has more upstream capacity than DOCSIS 1.0. It's 6 times more, 3 times more than DOCSIS 1.1. It has an improved robustness against interference. Now with DOCSIS 3.0, it's backwards compatible with the other DOCSIS versions, but it adds what's called channel bonding to increase the channel capacity. DOCSIS 3.0 gives you higher data rates with the channel bonding, more subscribers per channel, statistical multiplexing from channel bonding, better bandwidth utilization, the source specific for a multicast header suppression, high quality IP video with an increased quality of service, the ability to have more IP addresses by implementing IPv6. DOCSIS 3.0 has enhanced security. It has a 128-bit encryption, increased cable modem provisioning process security as well. The option to increase upstream bandwidth, option for 5 to 85 meg upstream support. It also has a powerful reporting to manage traffic. There's higher data rates which this is the key for 3.0. This is what makes 3.0 so appealing. Is that you're able to bond channels together using multiple upstreams and or downstream channels to get a larger logical channel. So instead of a single 6 meg, you can actually combine 4 of them together. That gives you 24 meg of bandwidth. The MSO can choose to bond any number of channels, and the channels do not have to be adjacent with each other, so they can be spread out throughout the spectrum. Individual channels supports legacy cable modems. It's fully backwards compatible. The minimum cable labs requirements is 4 upstreams and 4 downstream bonded channels. And this allows tiers of high-speed data services and enables business services. Your upstream capacity with a 6.4 megahertz and a 64 QAM with 2 channels bonded gives you 60 megabits per second. With 3 channels gives you 90, and with 4 channels it gives you up to 120 megabits per second. Your downstream capacity within the 6 megahertz bandwidth and a 256 QAM, 2 channels gives you 80 megabits per second, 3 channels bonded, 120 megabits per second, 4 channels, 160 megabits per second. And if you bonded 8 channels together, you would actually get 320 megabits per second. This is kind of an example of what channel bonding looks like. Let's say, like in this case here, that it's 160 megabits per second of data that you're wanting to send down the pipeline. What happens is that 160 megabits gets broke up into 4 individual segments, 40 megabits per second each. So it separates on those particular RF channels. It's then routed through your network, combined back together, and it gives you 160 megabits per second data output. So a DOCSIS 3.0 summary is you get more speed, more revenue per channel, guarantees on video quality due to the QoS, the quality of service, transition to IPv6 when ready gives you the ability of more IP addresses. Option to increase the upstream bandwidth, which increases your capacity. But before you can actually use DOCSIS 3.0, it's important that you qualify your plant. You do that by making sure that the head end, the RF, is properly aligned. You want to test your downstreams. We'll check the QAM carriers on your downstream to make sure that they're within its proper margin. You want to do your upstream 64 QAM testing and qualifications. Remember, a good tool that you can use with that is using your QAM source, and you can send a 64 QAM signal upstream to do your testing. You want to avoid frequencies near the roll-off or band edges. You want to avoid frequencies that's susceptible to ingress, if at all possible. And you want to control ingress, noise, common path distortions, and laser clipping, because those will affect the combined frequencies. You want to tighten your RF leakage thresholds, so signal leakage does not go away. You want to make sure that you keep your signal leakage tight. One of the ways of doing the testing of the bonded channels is by using auto test macros. This is an efficient, error-free testing. This is a good way of identifying, what types of problems that you're having on those bonded channels. DOCSIS 3.0 environment macro includes channels in a group, the channels that are grouped together, a set of tests to be performed on each one of the channels just to verify that each channel individually is working properly, because remember, these are bonded together, and one of the channels in that bond, if it's having a problem, it affects all of it across the board. Performance limits to analyze your test results. Once the macros are built and loaded into the meter, the technician simply pushes one button and runs a specific test on the specified channels. After the test is complete, the technician is then alerted right away if there's any failures that's happening on that particular DOCSIS 3 channel or the group of bonded channels. The technician can then retrieve and view supporting test details or save files for uploading to a server for further analysis. The field analyzer and DOCSIS 3 additional tests such as voice over IP analysis and CM, the cable modem statistics, can be run on any channels in the bonded group that's been configured as the primary channels. But now there's also tests that you can run using a DOCSIS 2 equipped meter as well. Because remember, with DOCSIS 3, your troubleshooting is not much different than what you would do today. The only thing is that you have to know what channels are bonded together just so that you can select, or that you can troubleshoot each one of the channels individually. So with the DOCSIS 2 meters, there's a full physical test. There's tests that you can test on the both the analog and the digital. There's the voice over IP, the high-speed data test suites, automatic data analysis health check, data up and download to the data management server. The tests are identical for both DOCSIS 2 and DOCSIS 3. There's your signal level scan, which measures the signal across the entire spectrum. This is useful for looking for if there's any suck outs or roll offs or things like that. It'll show that in your signal level scan. Spectrum analysis, that allows you to look at the actual spectrum, the spectrum itself. Remember, we talked earlier about the min hold and the max hold to do the spectrum analysis. The QAM EVS, which allows you to look under the QAM carrier for any type of distortions that could be impairing the QAM signal. The traffic control, we talked about that earlier, to where you can look at the upstream traffic and then also determine what type of noise is happening under that modem carrier. The upstream QAM source, which sends a QAM signal upstream that can be measured inside of the head end to verify what type of signal strength or power that's getting, how much insertion loss is happening from where you inject it to where you received it. The QAM level, just letting you know the level itself of that digital QAM. Constellation, which gives you the characteristics or the quality of the digital signal itself. MER, BER, and then also using a long-term BER to show you what types of impairments are coming into the digital over a time period. Some additional tests that you can run on the primary channels is voice over IP, cable modem statistics, which is called the CM stat in the 860 DSPI, conducting the ping, we talked about that, the trace route, and doing your high-speed throughput. The thing is, when you're checking for high-speed data, just remember that the high-speed data is still running on your QAM carriers for your downstream, and your upstream is also a QAM that's on the upstream. So you don't want to neglect any of your tools that can help you quickly isolate where your problem could be coming from. I trust that you now have a better understanding of how to actually properly troubleshoot high-speed data problems. I now will respond to chatted questions. Okay. Now I did have a few questions that came across. Some were actually related to the microphone usage and things like that, which I think as the webinar went on that you had, you understood that it was you had the ability of sending chat responses, and then we respond to those at the end. There was a question about the RSVP. You'll notice on the screen that there's a support forum, a support email, and a website address. Feel free, any specific questions that's not related exactly to the high-speed data, you can send those directly to the support at trilithic.com, and we have engineers that's waiting to respond to those. Now there was a question that was asked on trace route. Are the ping times shown cumulative or discrete to that particular hop? One thing about trace route, that it's going to actually clock or have the speed for each individual hop that it goes to up to 30 hops. Up to 30 hops, and it shows you the time that it takes, or the amount of latency between one hop to the next. Hopefully that answered that question. It's not actually pinging that particular hop. It's actually pinging the destination, but it's showing the route that the packets are taking. There was another one about acceptable ping times. This will actually vary depending on what you're trying to test. Because if you can remember, if you're wanting to test lost packets, then you want to send more packets at a quicker rate. But rule of thumb is, if you're comparing against what the customer's PC is, what it's seeing when they go into the command prompt, then I would set it at 32 bytes and at 1,000 milliseconds, because that's what they're going to get with the command prompt. But if you're really wanting to troubleshoot it down further, the best route to take is if you're troubleshooting gamers or something along those lines, it's probably like 512 bytes, larger packet size, and 200 milliseconds, which sends the packets faster. There was a question about the SNR, upstream SNR greater than 30, and then tying that in with the pre and post BER worse than 1E minus 5. One of the things is I'm not sure exactly the nature of that particular question, but what I do want to let you know is that when you start talking about your SNR and then also your BER, just remember, you really don't want the BER to fall below, minus 0.8. That's kind of an industry standard. No lower than minus 0.7. Your post, you always want that to be able to address any or correct any errors that were there. For latency and jitter, what are the optimal specs? For latency, you don't want that to exceed 200 milliseconds, no more than 200 milliseconds. For jitter, you don't want that to exceed 50 milliseconds. And remember, latency is how much time it takes to get from point A to point B. Jitter is a buffer that corrects timing sequences for your voice over IP. Question about this webinar in general, as far as if you have ability of getting copies of this or what have you. We will have some posts on for this, as well as other training aids, on our website, which is you'll see it listed there as www.trilithic.com, and you can get some of this information. Also, this particular presentation was recorded, and it's going to that particular link would be available as well for those who missed it, or if they just want a recap. Let's see. When reading channel bonded channels, can you read them individually with a DOCSIS 2 meter? Yes, you can, because remember, when you're talking about channel bonding, it's still the individual QAM channels that are bonded together. So in theory, if you know that, for the sake of argument, let's say there's channels 62, 63, 64, and 65 that are bonded together, then you could use your QAM or your digital analyzer and look at channel 63 and look at the constellation and your MER and BER, and see if there's any problem with that particular channel of that bonded set, or you can individually look at all of the others, or do the auto test, which makes it easier. Let's see, when you say run traceroute in your own network, do you mean your local CMTS, or would it be better to ping to the NOC? What I'm actually saying is that that the network that you control is up to the CMTS. So what you don't want to do is that when you're trying to troubleshoot a network problem, is to go directly to like Yahoo and then and then know that that's the actual problem. What you want to verify is that can you ping something right to your network, right at maybe the gateway, right at the head end. Can you ping that particular location? If everything is clean to that point, but yet you're losing it to Yahoo, then you know that, okay, there's a problem that's outside of your network, which is beyond your area of repair if you're the technician that's in the field. What does laser clipping look like on the spectrum analyzer? I'm actually next week I'm going to do a webinar on spectrum analyzer in general, which will help with that question further. But it'll look like you'll see like vertical lines, or a noise floor that is exaggerated. Because remember, laser clipping is a form of an overdriven laser or an overdriven amp, so it'll look like distortions. Where do I find traceroute test on my 860? That particular test is on the 860. You might want to contact Trilithic directly. You can call the 1-800 number to get the specifics on how to set up that particular test. So question, we have inserted a 64 QAM carrier in our upstream to very good constellation and MER performance. Unfortunately, the carrier carries no baggage, so there is no sync lock nor BER performance specs. Can I assume that a good MER greater than 37 will equal good BER performance? Should we add data to that QAM carrier? I mean, if you have data, it's all the better, because it's looking at exactly what the customer is going to see. But if you're getting a good MER, your BER is probably going to be pretty good, but it's not going to necessarily run one-to-one because it is doing different measurements. The MER is measuring the digital quality itself, similar to like a carrier to noise type measurement. I'm talking about the quality, whereas the BER is looking for any bits that did not arrive at its destination or that dropped out or whatever the case is. So it's two different measurements, and both are equally important. So another question, let me see, we're troubleshooting high bit errors according to our market health tools. I think that's still all part of the original BER question. Let me see. Is traffic control an added feature or an upgrade to the 860? That's also another a good question that you can call in directly into the 1-800 number 344-2412, and we can give you the specifics on traffic control if you're set up to be able to do traffic control and so on. Can you set the meter to record levels between a certain time frame? Now, I'm assuming this is talking about being able to start the meter at one time, record levels, and then set it to measure levels again. Yes, you can by using the auto test. You can set up auto test macros, and it will allow you to set specific times or a specific time frame and the duration of a test. You can set that with your auto test macros. See, when using traffic control, how do you interface to the meter in order to see live traffic at the customer premise? When using traffic control, how do you interface to the meter in order to see live traffic? Oh, if I'm understanding what you're saying is when you're using traffic control. When you're coming right off of the back of your modem, for example, what you need to do is that you would need to split off or DC off so that you're seeing that traffic that is going back upstream without taking the modem down. Because what you don't want to do is you can't just plug your modem or plug your meter directly into the back of the cable modem just because of the fact that you no longer have cable anymore, so it's not going to send any packets. So in order for you to see the traffic, you would have to DC off or split off of the input, or if you were out at the tap, you would be able to go to the KS port or your seizure screw there, and you would be able to see any traffic that's going across. The last question, let's see. Let's see if we can get the last question in here. In an existing 3.0 environment, the 860 cable modem statistics option, how do you enable the change ID to change the upstream frequency? It's actually by hitting your function key, and then it gives you the option to change your upstream ID. If you have problems with any specific things on the 860 or really any of our tools that we have, feel free to give us a call into the office at the 1-800-344-2412, or the best method is to send an email directly to support@trilithic.com, and then we can address all of your questions at that time, and then we can even give you even more details of some of the things that we've talked about here. All right, so I'm hoping that that something in the webinar helped you or will give you a better idea of how to troubleshoot high-speed data. Just so you know, Thursday of this week, and you can look on our website for more information, we'll have a home certification webinar that's going to go all through, how to certify a home. Next week we're going to be covering Spectrum Analyzer, how to set those up, how to use it to do your testing. We'll also talk about later in that week signal leakage and some other things. So continue to check our website. You'll be able to get a lot of good information from there as far as some of our upcoming events. And any other questions that I didn't address, or maybe I misunderstood the question, feel free to send an email to support, and then we can address all of those questions. All right. Well, thanks for your patience, and I look forward to seeing you at our next webinar session.